Hi, Zach Hartle here. Welcome back. I want to talk today about the idea behind adding phasors together. Now, when we're talking about phasors in electrical theory, phasors are there to represent the magnitude of a current or a magnitude of a voltage in different types of circuits. So what we have here is a circuit which has a current as a reference and then two different volt drops in this circuit. Now, somewhere where you might see this would be a series circuit, right? If we're talking about a series circuit which has two different coils connected up to an AC source. Now, knowing what's going on here isn't overly important right now. All we know is we have to remember that in a series circuit, our voltages add up to make the source voltage. So in this case, we've got voltage 1 and voltage 2. When we add them up, it should equal our source voltage. Now, when we look at these two phasors, we can't simply take the length of phasor 2 and add it directly to the length of phasor 1 because they're occurring at different times. They're also occurring at different angles. However, what we can do and what we need to do is if we take this and we imagine V1, something like this. There is, with V1, a horizontal component and a vertical component. Same thing goes with V2. V2 is more like this. V2 also has a horizontal component and a vertical component. Now what we can do with phasors is we can take our horizontal components and our vertical components and add them together. So if we take the horizontal value of V1, add it to the horizontal value of V2, right? So in this case, we would take V1, add in the horizontal component of V2, which is about this long, right? That gives us a total, right? So horizontal of V1 plus horizontal of V2 equals horizontal total for both. Then we do the same thing. We're going to take the vertical of V1 plus the vertical of V2 gives us our V1, our vertical of V1 plus vertical of V2 equals vertical total, right? So we're adding up the verticals on both of these. It's going to give us our VT. And then what we do is we connect the dots and we make our voltage total, or our hypotenuse of a triangle, right? And then using Pythagorean's theorem, we can actually solve the magnitude of our VT, right? So that's what we're doing when we're adding up phasors. Use Pythagorean's theorem, solve that, then use any one of our trigonomic functions to solve for theta in here. And then based off of our reference, that can tell us where our total voltage will be. So make sure you check out some future videos. I'm going to do some examples with numbers, and we're going to put all this information into what's called an HV chart. Basically, an HV chart will be V1 at some type of angle plus V2 at some type of angle, and we're going to add up the horizontals and add up the verticals to get our VT at some type of theta. Right, so exactly what we've done here. This is just kind of the basics of it. Thanks a lot for watching. Have a great day.